Hi dear students, today I would like to explain electric current chapter for 10th class students. See, in this chapter we have the topics electric charge represented by capital Q or small q. The formula will be plus or minus Ne. Ne means number of electrons or protons. E means charge of an electron minus 1.6 into 10 power minus 19 coulombs. And electric current represented with capital I as small I. Formula will be small q by T, charge by time. Electric potential, we don't have any symbol for this. Potential difference or voltage V equal to W by Q. W means work done, Q means charge. Ohm's law, we have the formula V equal to IR. I means current, V means voltage, R means resistance. Next, resistance R equal to rho L by A. L means length of the conductor, A means area of cross section of the conductor, rho means resistivity or specific resistance. From this we will get the formula rho equal to RA by L. Series and parallel combination of resistors. Electric power P is equal to voltage into current. Power means voltage into current. Electrical energy E equal to voltage into current into time. Energy is nothing but power into time. Power means V into I into T we need to write. Kirchhoff laws, we have two laws, Kirchhoff current law, Kirchhoff voltage law, or Kirchhoff first law or Kirchhoff voltage law. Kirchhoff current law works on the principle of law of conservation of charge. Kirchhoff voltage law works on the principle of law of conservation of energy. Now, types of materials. We have three types of materials: conductors, semiconductors, insulators. Conductors are nothing but the materials which can allow the current through them are called conductors, and the materials which allow the current partially through them are called semiconductors. The material which does not allow the current through them are called insulators. For conductors, example all metals. Why? Because they having the free electrons. Semiconductors, example silicon and germanium and diodes, transistors are the examples. Insulators are nothing but wood, plastic, paper. So they won't allow the current through them or flow of electrons through them. Next, electric charge we can represent it with capital Q or small q. See, electric charge is nothing but it is the intrinsic property of material. Intrinsic property is nothing but the internal property. Suppose if the teacher having teaching is the intrinsic property. Suppose the doctor having treatment, he will do treatment for the patients. So the treatment will be the property. So for the material also we have intrinsic property, that will be the electric charge. Electric charge formula Q is equal to plus or minus Ne. N means number of electrons or we can say number density. E means charge of an electron. Value minus 1.6 into 10 power minus 19 coulombs. Units for charge is coulomb. Simply C we can take. And here if you take plus value, that will be the charge of proton. Types of charges: positive charge, negative charge, neutral charge. Positive means plus, negative means minus. In the atoms we have subatomic particles, protons, electrons and neutrons. The particles which can present in the nucleus are called nucleons. Nothing but neutrons and protons are the nucleons. The particles which can present around the nucleus are called electrons. Electrons having less weight compared to electrons, protons and neutrons having more weight, more mass. Coming to here, suppose if any substance having different shapes, suppose I took here rectangle, circle, and this will be the different shape. So for any shape of material having equal number of protons, equal number of electrons. If you observe here, we have 5 protons, 5 electrons. That's why we can write plus or minus 5. For this, 4 protons, 4 electrons, plus or minus 4e. Here 5 protons, 5 electrons, we can write plus or minus 5e. For any shape of the material, we have equal number of protons, equal number of electrons. Coming to next condition, like charges are repel each other, unlike charges are attract each other. This is the property of the charges. Like charges means either plus plus repel each other, minus minus repel each other, plus to minus, minus to plus attract each other. Like if for the magnetism, if you have the different poles, suppose north and south attract each other, north north, south south repel each other. Like poles are repel each other, unlike poles are attract each other. So this is about types of material and electric charge. Now electric current we can represent with capital I, a small I. Current flow we need to compare with water flow in the pipe. How the water is flowing in the pipe, same in the way the current is flowing. So we need to compare the current flow with water flow in the pipe. The definition will be the rate of flow of electric charge or electrons in a conductor or in a circuit is nothing but electric current. Formula will be I equal to Q by T. If we have the time in the denominator, we need to start the definition as rate. So the rate of flow of electric charge in a conductor is nothing but electric current. Units will be coulomb per second. Units will be coulomb per second or ampere. So 1 ampere is nothing but 1 coulomb per second. Formula for electric current is capital A. And I is a scalar quantity. See, if you observe the current flowing in the wire, current having some direction and the magnitude, but it is not a vector. Why? Because the current does not obey laws of vector addition. Nothing but suppose if we have different directions, 2 ampere and 1 ampere moving towards the junction, for the outside you will get 3 ampere, 2 plus 1 3. This will be the algebraic addition. For the vector addition, we need to take the angle and apply the parallelogram law of vector addition property. That's why, but coming to current, current is a scalar quantity because it does not obey laws of vector addition. It is very important. And we have two different types of current. One is conventional current and electronic current. Conventional current is always flow opposite to the flow of electrons. The electrons are moving from negative to positive, then the conventional current is flowing from positive to negative. So the conventional current we need to take maximum to solve the problems. So it will be flow from opposite to the direction of flow of electrons. Electronic current is nothing but the current which will flow in the direction of electrons. In the direction of flow of electrons is nothing but electronic current. So if the electrons are moving from here to here, then the electronic current also moving from negative to positive. But conventional current is always opposite to the flow of electrons. Current values measured by using ammeter. This will be the symbol, ammeter symbol. We need to take capital A. So and always connected series in the circuit. In the circuit we need to connect ammeter in series. I always flow from higher potential to lower potential. How the water is flowing from higher place to lower place, same. The current also flow from higher potential to lower potential. And to flow the current in the circuit should be closed. For the closed circuits only, the current will be flow in that circuit. And to get the maximum current, the circuit should be short circuit. For short circuit, maximum current will flow. So this is about current. For electric potential, definition will be the work done is required to bring the charge from infinite to finite is called electric potential. See, for this drawn diagram, if you observe this one, this is the atom structure. So atom we can represent with nucleus and we have the different shells. So in the shells the electrons are revolving around the nucleus. In the nucleus we have nucleons. Nucleons are nothing but protons and neutrons. So outside the nucleus the electrons are revolving in the shells. We have K shell, L shell, M shell, N shell, like that. So here suppose the electron or electric charge will be the infinite distance from the nucleus or from the atom. To bring the electric charge from infinite to finite distance, we should do some work. That work will be the electric potential. Suppose I will explain one practical example to explain about electric potential. Suppose the person is doing some work to bring the chair from the infinite distance. He need to bring the chair from infinite distance to finite distance. Here we need to consider chair as electric charge. So to bring that chair he need to do some work. So that work will be the electric potential. Next, potential difference or voltage we can represent with capital V. So capital V formula W by Q. Work done by charge is nothing but potential difference or voltage. So the definition will be the work done is required to bring the charge from one point to another point. Suppose in the third shell we have the electron. To bring that electron to the first shell, nothing but one point to another point, we need to do some work. So that work is nothing but potential difference or voltage. So voltage is nothing but work done by charge. Units will be for work done joule by charge means coulomb. Joule per coulomb or volt. Volt will be the scientist name. So 1 volt is equal to 1 joule per coulomb. And here voltage values are measured by using voltmeter, always connected parallel in a circuit. And in the open circuit we get maximum voltage and the current will be 0. And main important point here, the voltage or potential difference we need to compare with water tank. Practical example, water tank. Without water tank there is no water flowing in the pipe. Same thing, without the voltage there is no flow of current in the circuit. Voltage or battery voltage. So voltage we need to compare with practical example, water tank. So this is about electric current charge, electric current and potential difference and electric potential.